Transformation, we will be doing 4 or 5 of them, of a geometric figure is a change, and I have posted these PDFs now, in the position, size, or orientation of a figure. Transformation is a change in the position, size, or orientation. It could be and or of a figure. Yes? This is CC6. Okay, so this is called CC6, formerly 9.1. Where's your homework? Is it in the textbook or is it online in CC6? Online in CC6. So what the publisher has done is they have taken their chapter 9 and they've aligned it to the Common Core. That is orientation. No, this is on another sheet of paper. I'm not on the foldable yet. You just have your foldables ready. I told you that earlier. Okay, isometry is a special transformation in which the pre-image and image are congruent. And I'm going to put in parentheses same size and shape. So an isometry has not changed any lengths, any angle measures at all. The pre-image is the original. Figure. Pre for before transformation. I'm going to drag this up. Image is the transformed figure. How else could I say this? I could say this figure after the transformation. And it's really important that you understand in any problem who is the original and who is the image. Otherwise, you're going to get the descriptive rule that tells you what one was or what happened wrong. And I believe that a lot of this is going to be done on the coordinate plane. Did you have to flip something yesterday? Over an x-axis? Okay, and was it on a coordinate plane? Oh, was it on graph paper? Did they give you coordinates? If they gave you coordinates, then would it have been on graph paper if you had plotted it? Yes, I think that's what they're going to do a lot on this piece. And I don't think the book had very much coordinate graphs with this lesson. So another study tool is that Khan Academy and going to the standard and looking at what kind of practice problems they have there. All right, so now the question is, do we have isometry or not? Now remember, let's go back. What is an isometry? The pre-image, that means the original figure, and the image, the transformed figure, are what? Congruent, same size and shape. All right, so is this an isometry? Yes. Because it is the same size and is this an isometry? It is the same shape, but it is not in the same size. Is this an isometry? Is this an isometry? Okay, is that easy? Oh, what are those? That's an isometry. All right, so let's talk about notation. This is the pre-image. What's another name for pre-image? Original. Will we use the word original? No. And this is the image. And I have not done this very well. So this should be here, and this should be here. When we do, one way in a picture that you know who is pre and who is image, the pre will always have ABC with nothing attached. That's A prime, B prime, C prime tells us that that is the image. That this, I can't label this vertex A because this is A, so we make that A prime. We make this A prime so that you know that this is the image of this, that this vertex matches that this vertex matches this, and that vertex matches that. What did they do to go from the pre to the image? They flipped it. They flipped it. That's called a reflection. All right, if we look at this one, we have A, how about M-A-T-H? So notice M primes corresponds to your M, your H prime to your H, your T prime to your T, and your A prime to your A. They think they have rotated this figure too. I would have to turn this, I think, in order to, you see it? You see what they did? Okay. Now, this is another way they're going to do it. Math, and they have this arrow to M prime, A prime, T prime, H prime. This says math is mapped onto. So this is the original, and this is the image. When you take a picture, your picture is an image. You are the what? Original. You with me? Are you, in the picture, are you a different size? You're a lot smaller, right. That is a transformation. Is that an isometry? No. We'll talk about those last. Okay. So now, which is, typo, the image and which is the pre-image? Now notice there are no primes, are there? No primes. So how are you going to figure out who is who? You're going to look at this. So this is the pre-image. Is this the original? No. Who's the original? How do you know this is the pre-image? Because it's the one they start with, and the arrow is pointing to its image. So this is the image. Do you understand your notation? All right. CC5 was an investigation that introduced you to translations, rotations, and reflections. Investigation on page 46-47 introduced you to translations. And let's talk about that for a minute. If I had a triangle, what basically did you do to this triangle on that investigation? Do you remember? Did you rotate it? Did you slide it? Did you flip it? What did you do to it? Do you remember? You slid it. Do you remember that arrow you made? Didn't you have an arrow going from one? And didn't you have to put a spot on somewhere on that arrow? Yeah, on the patty paper. And do you remember that you had to take this and put that on the spot? Do you remember that? And do you remember that I asked you to draw, you had to take another sheet of patty paper and measure, draw that segment, and this segment from here to here? Look at those dotted lines. What can you tell me about those dotted lines? What word would you use from our last unit? We found the slope. What are they? Parallel. They are parallel. And what did you know about the distance between each set of these points? They were the same. So this is a situation where we have slid the figure, and when you slide a figure, it is called a translation. Now, will I call it a slide on a test, or will I call it a translation? Translation. Okay. Translation is an isometry that maps all points of a figure the same distance, no, in the same direction. Translation is an isometry, meaning it produces congruent figures. We didn't change its shape. That maps all points of the figure the same distance. That means O, O prime, C, C prime, D, D prime are all congruent and in the same direction. So we didn't slide O up here and D down there. Does that make sense? They all had to slide the same way. Note that the dotted lines are parallel. And corresponding sides of the triangles are also parallel. So the sides of the figure of the image will be parallel to the sides of the pre-image. All right, so now this is where the book and the Common Core start to diverge. This is the notation that Common Core uses. This is the notation right here that the textbook 9.1 uses. This is CC6, this is 9.1. And so I had written all these notes with this notation and then discovered the CC and discovered that it was all in this notation. But you need to be able to work with both because, to be honest with you, I do not know what your EOC will use. What this does is it tells you to add 2 to the x coordinate, add 2 to x, and it tells you to add -3 to the y. So on a translation, this refers to x and this refers to y. So I might write this way. And is that really obvious that you're supposed to add 2 and subtract 3? Or I may write it this way. And I think in your homework I've asked you to write it both ways. And this means add a +2 to x, add a -3 to y. So literally, if I want to transform point P, then literally after this translation, P prime is going to be 9 minus 2, comma, -5 plus 5, or P prime is going to be 7, 0. Was that hard? Okay. We want to translate this point. This says move it 2 units left and 5 units up. So that means that I have to add 2 to 9 and let's see, I have to subtract 2 from 9 to go left, and I have to add 5 to -5 to go up. So think about it. If you're below the x-axis 5 units and you move up 5, aren't you going to be at 0? All right, so let's do this transformation or translation for the same point. What does that mean? Notice I'm using my prime. The image will be 9 plus 0, and the y-coordinate will be -5 plus 6. So the image point is going to be 9, 1. Pardon? You can do this, I can do this without even looking at graph paper, just by doing what they said. This means xy is being transformed into x minus 8, y minus 4. That's another way to write this statement. So if I want to transform this P prime is going to be the 9 minus 8 and -5 minus -5 minus 4. So that means P prime will be 9 minus 8 is 1, -5 minus 4 is -9. So who wants to do this one? Do I have a volunteer? Nick? So it's going to be, so if I did this notation, this means x plus 5, right? Okay, so now do it to my p. 9 plus 5, comma. So p prime will be 14, comma. Right. Are you liking this? Do we have to know anything about a midpoint to do this? Do we have to know anything about a corresponding angle to do this? Is this a clean start? Yes. This is a clean start. All right. So now you have your foldable, correct? So here we go. We should be on the translation flap. Open it up. Open up your translation flap. First of all, I want you to know it's an isometry. Inside, Start at the top. It is an isometry. Properties of a translation. It preserves, I think I'm going to put length. It preserves length. Oh, that's not going to help me, right? Let's try this again. It preserves length. It preserves angle measure. Because if two figures are congruent, their lengths and their angles are going to be congruent. And it preserves orientation. Okay. So, if you want to write this on your other sheet of paper, let me explain orientation. This is A, B, C. This is A prime, B prime, C prime. Notice this is a clockwise direction. This image is also a clockwise direction. If I had it this way, A prime, B prime, my prime's in the wrong spot, C prime, do you agree that's counterclockwise? That's a change in orientation. That's what we mean about orientation. That means if we start here and go A, B, C clockwise, we're going to do A prime, B prime, C prime clockwise. Change in orientation would be different. It maps each point of the pre-image to a corresponding point on the image. Sides of a figure are congruent under a translation. So this notation means x comma y becomes x plus 4, y plus 8. I'll make it even more explicit. It means add 4 to every x value and add 8 to every y value. That should be on the inside of your flap. Preserves length, it preserves angle measure, it preserves orientation. It maps each point of a pre-image to a corresponding point on the image. Sides of figures are congruent. Oh, I don't want congruent. I want parallel. Or we could do both. Sides of figures are congruent and parallel. I think so. Let's go to the next page. All right. So now what if you're on graph paper? Look how easy this is. What does this say if I'm on graph paper? It says move each x what? To which direction? To the right. And then what? 3 down. So do you see this A? 1, 2 to the right, 1, 2, 3. C, 2 to the right, 1, 2, 3. So that's C prime. This is A prime. You got to label your vertices. 2 to the right, 1, 2, 3 down. B prime. Guess what? Right there is your image. Do you see how it slid? Are your sides parallel? Are your sides congruent? Are your angles congruent? Was that hard? You like this? Simple. All right, now, given a quadrilateral with vertices whose coordinates are, perform the translation. What does this tell you to do? 4 down, 8 to the right, and identify the coordinates of the image. I'm not on graph paper, so we don't have to be on graph paper. So I'm going to say that T is going to be, T prime is going to be -1 minus 4 and 2 plus 8. Or my new T prime is going to be -5, 10. My R prime, let's see. Karen, you do R prime. Okay, what does this tell us to do? -4, and then my Y is 3. What am I doing to 3? Right. Up. There's my 8. And so R prime is going to be -3, 11. All right. Samantha, you get A. Why? That's a positive 8.
No, 1 plus -4. 1 plus -4.
You didn't see my negatives too tiny. Okay. Samantha, A. It is plus -4. Right. So what is A prime going to be? Okay. You have $3. You owe $4. -1, comma, 11. All right, let's do P. P prime, Kayla Shipley.
-1 minus 4 6
Mm-hmm.
6 plus 8.
Right. So your P prime is -5, 14. Now, if you graph those, it should be a slide, and side should be parallel and side should be congruent. What happens if one of your sides is really big? What does that mean you did? You goofed somewhere. All right. So how do we do this? What am I supposed to do, Travis? What does this tell me to do? Move 5 units to the right. So 1, 2, 3, 4, 5. 1, 2, 3, 4. That is P prime. So we're going to do 1, 2, 3, 4, 5. 1, 2, 3, 4. That is A prime. Don't pack up yet. My clock is fast. 1, 2, 3, 4, 5. 1, 2, 3, 4. And that is W prime. Is it important that you use primes? Yes. So now if I connect these, they should be congruent and the sides should be parallel. Does it look like it was a slide? Okay. So give the translation rule that maps quad onto Q prime, U prime, A prime, D prime. So this is the pre-image, this is the image. So to do the rule, you're going to do T, and this is a subscript. What did I do? I'm going to need two numbers. I need a horizontal and a vertical. What did we do? To go from Q to Q prime. 1, 2, 3, 4, 5, 6. How many units did I move? In what direction? Positive, okay? Now from here I have to do 1, 2, 3, 4, 5, 6, 7, 8. And I went up, so it's 8. I also want you to write it x comma y maps x plus 6 comma y plus 8. I want to see both of these notations because I don't know what they're going to do on the EOC. When we looked at the EOC test specs, they went ahead and they were doing this instead of this, though this was Common Core.
What T for that?
T for translation, capital T. This is a slide. Translation is a slide. Yeah. All right. So let's see. What else? Do I have to teach you anything else? Now, perform the translation where we shift only 2 over. 2 to the right, that's A prime. 2 to the right, that's B prime. 2 to the right is C prime. Okay? Then what's the next one I'm supposed to do? That says to do nothing horizontally, but now move each one of these down 3. So what that means is, and it should be then, you see then on this, now perform this. So I don't go over, I just go down 1, 2, 3. So that's a double prime. Why am I using double prime? Because it's a second translation, 1, 2, 3. That is B double prime. So this is my new shape. This is the point I want to make. What if I had done a translation that was 2 comma negative 3? I would have gone to the right 2 and down 3. Would I've already made it to A double prime in one step? Do you see that? Okay. So we can take this translation and we can break it up into 2. We can say, all right, we're going to translate this open circle means a composition of translations. We always start inside and we work outside. So what this says is move to the right 2 first, then it says take that new figure and move down 3. This translation up here is equivalent to this composition. It's just breaking this translation into its horizontal and vertical components. So every translation can be done as a combination of 2 or more. You can perform a horizontal translation followed by a vertical, vice versa. So if I want to make this into a single translation, then it's going to be negative 3 comma 4. Why does 4 go last and negative 3 first? Does it make sense that negative 3 was in the x position and 4 was in the y? If we want to do this in one translation, what do we do? 5 comma negative 7. That's part of your homework. So as anything, now we're going to reverse it. Rewrite as a combination of a 2. So you're going to translate negative 6, 0. Then you're going to translate 0, negative 1. So we're undoing what we just did. We're going to translate 12, 0. Then we're going to translate that figure we just got 5 up. And I think that then ends this first piece. So I think you're going to enjoy this unit because it's just kind of moving figures around. So where is your homework? Not in the textbook. It is online under the book category, and it is CC6.